Okay, good afternoon, all of you. Today we see the decision tree. As we discussed in the previous class and all, there is a different algorithms we discussed. One is support vector machine, then naive Bayes algorithm, then another one is k nearest neighbor. All these things is able to classify your data set. Similarly, now we'll see our the classification in this last algorithm. Let it be as a decision tree. This also, we know that all these algorithms related to the supervised learning techniques only. But also, with respect to the previous algorithm, this also can capable of doing the both things. One is classification as well as the regression problems. But normally, we'll preferably to use to solve the classification problems only. And then it is a true structured classifier. The internal nodes represents the features of the data set, and branches represent the decision rules, and each leaf node represent the outcome. So this is something like a tree fashion. So there is a first one we can see that there is a root node we have to identify. From that, we have to go for as up to the leaf node. So that is the process we are doing here. And we also identify which one is the root node, because many features are there where to start. That is also as a major concern in this aspect. Then the decision tree, there are two nodes majorly. That is a decision node and leaf node. So decision node are used to make any decision and have multiple branches. So as I said, now we start with one node that we call it as a decision node, and thereafter we are going to divide the classification up to the leaf node. And whereas leaf node are the output of the those decisions. So and do not contain any further branches. Once if it happened in the leaf node, that is a final in that case. So after that, we don't have any provision to divide further like that. These decisions are tests are performed on the basis of a features of the given data set. Normally, any data set, what we have is some features are there, and one is a target output or called as an output. So based on the features, we are going to find your decision. That's what you can say that our output. And it is a graphical representation for getting all the possible solutions. Means we start with one feature. How to select that feature, we'll see. One feature as a root node. From that S or no concept. It is all about 0 and 1s or S or no, true or false, like that. It is going to be divided, and finally it has to reach the solution to the problem decision based on the given conditions. Based on the condition, it has to decide. Suppose whether something like you want to play as a tennis, or to go for as a gym, or something else you want to play for cricket, or you want to go for movie. For that, what is the decision? So in that case, what we'll do is we have to divide based on the features. We have to consider that condition, and we have to decide whether we are going for gym or not. What are the features we may have, weather condition, are based on your energy, and all many features we will consider. On the data set we may have already based on the features whether we are going for as a what you call it as gym or not. So that is only your concern in this case. Now we can see, as I said, a decision tree is nothing but a tree structure. So in that, lot of features are there. In that, one of the feature will consider as a root node. This first one will start somewhere, and then we are go on segregating. This we call it as a root node. First pick up one. How to pick up? There is a process again. At moment, first one of the node or one of the feature you consider as a root node. That is also called as a decision node. And it will divide again. First node may be weather condition. So whether yes or no. If yes is a node, in that again you have to check with some other conditions like this. And if it is no, also some other conditions you have to check it. So like that, we are dividing further and further. And once if you subtree got it, from that, it may be yes or it may be no. And in this decision node also, it may get yes or no. And other side also again we can divide in this fashion. This may be again decision tree. And here also you want to divide, you can divide it like that. We are keep on dividing the data in the sense in the terms of the future, and conditions we can able to judge. So this is the structure. Now that's what I mentioned here. It is a decision tree because similar to tree only. Whatever we are dividing here, the features, it is going to be as a tree state. And it starts with root node, branch, and then it further branches and construct a tree structure. So in this fashion, we will get it. In this, in order to build a tree, how this is going to be developed, for that we have as algorithms. In that, there is a CART algorithm is used, which starts a classification and regression algorithms. And a decision tree simply ask a question. Suppose this is a starting point, whether you are going for something gym or not. That is the final target. Here it will get whether you are going to gym or not based on this condition. This condition may be weather. This condition may be energy. This condition may be emotion. Whatever you want in the different feature, you are able to consider, and finally you have to decide your answer yes or no, or true or false, or 0 or 1. It is further split the tree into the subtrees. This is what we are able to. One subtrees again they have leaves and so on. So in this, there is a lot of algorithms we are going to use. This is the ID3 algorithm, extension of D3 algorithm, successor of ID3. And then, as I mentioned, this is a CART algorithm we are using, classification and regression tree. So this algorithm, we call it as a classification and regression tree. And there is a chained CHOID. So that is a squared automatic interaction detection performs multi-level splits when computing the classification tree. Like that, we may have the different categories. We are going to solve our problem using any of the algorithm, but all comes under decision tree only. Now, this way also you can split. That is first root node, then splitting based on your conditions. Decision nodes we have, and again further you can divide terminal load, and then again decision node, and finally once it reaches to the leaf node, we can stop it like that. Why use the decision tree? Two reasons for using the decision tree. One is mimic human thinking ability while making a decision. So it is easy to understand. That is also one reason. Logic behind the decision tree can be easily understood because it shows the tree-like structures. So the way it is going to be divided, it is easy for us. So that is one thing. And terminologies you can see there is a because in the decision tree we are going to use some terminologies because the root node is there, leaf node will be there, decisions are there, like that. Some preferable terminologies are very important. In this first one, root node. Root node is from where the decision tree starts. That's what we call it as a root node. Wherever you are starting, any one of the feature will consider as a root node. And that meaning is wherever your starting point or a starting point of the data set that consisting of the all the data set information in the what we call it as a root node, and entire data set will be there. It represents the entire data set because we are starting as a parent, or you can say it will be the starting point, or you can say that entire data set. So again, it will further divided into two or more homogeneous sets. So it depends on our requirement. I used in this case of decision tree, what we can get is more homogeneous sets. That let it be as a next one is a leaf node. So what is the leaf node here? Final output node. So we are keep on dividing sub parts. Finally, somewhere we have to stop. Where to stop? That is a leaf node. Leaf node are the final output node, and tree cannot be segregated further. That's what I observed. These are the two terminologies must remember. One is a root node that we call it as a decision tree starting point, and leaf node is an ending point. You can see that the further will not be going to be divided. That is what we call it as a ending node. And splitting. Splitting is the process of dividing the decision node or a root node into subnodes according to the given conditions. So the based on the condition, whether it is a true or false, based on that, we are going to divide our subnodes. So if the condition is true, then we are dividing one side. If condition is false, then you can divide other side like that. And subtree or a branch. A tree formed by splitting the tree. That is only the subtree. Means you are starting, this is a what you call it as a root node. And again, we are dividing like this. There is a another node. And again, you are dividing like this. There is another glow like that. We are able to keep on getting this is a decision tree. So after that, you may reach to the decision. So this is what we are able to find. And now pruning. So this is a pruning is a process of removing the unwanted branches from the tree. So if there is no significance in that, what we'll do is that we call it as a, we are going to remove that branch. So that is what we call it as a pruning. Pruning also need to do if that there is no significant in that branch or in that particular node. In that case, we can say that pruning is the process of removing the unwanted branches from the tree. And there is a parent or a child node. The root node of the tree is called a parent node. I already mentioned the previously. So these are the, we call it as a first one, is nothing but a root node, or you can say it is a parent node. Like that, we are able to divide the parent or child node. The root node of the tree is called the parent node, and other nodes are called as a child node. So this is quite common because it is in tree structure. So starting point is always as a root node, and go on dividing this. Finally, it will reach us to the leaf node. So how does the decision tree algorithm works? How it will be works? We'll see some points. For predicting the class of a given data set, the algorithm starts from the root node and compare the value of the root attribute with the real data set attribute. Based on the comparison, follows the branch or jump to the next board. From the next node, means for the next node, algorithm again compared to algorithm again compared to attribute value with other subsets as mentioned, and it continues the process until it reaches a leaf node as a final. So leaf node is the node of the tree. So therefore it continuously process until if we reach the niche. If we reach tree, what you call it as leaf node, you can stop your processor. And now complete the process and better understanding using the algorithm. This is already mentioned. Another one, there is a different steps are there. Step one, begin the tree with the root node, or we can say that S is a symbol which contains the complete data set, any variable name you can use it. And this is a root node. From the root node, if we want you have to do is data set are using. So that's what we can say that best attribute in the data set using attribute selection measure ASM. This is the attribute measure selection, attribute selection measures. That is second step. Third step is divide the S into subsets that contain possible values. That contain possible values means what? So best attribute. So whatever the previous algorithms also there, what we are doing is we are able to find the optimal hyperplane or a division or a partition of thing, something like that. We have to go for as a best attribute. And generate the decision tree node which contains the best attribute, and then recursively make new decision tree using subset of the data set created by the step 3. So from this, we repeated this program. Finally, we are able to decide. Continue this process until a storage of reached where you cannot further classify the nodes called as a final node or a leaf node. That is what we can able to mm, divide. This is the procedure of a decision tree. Just a minute. After that, what we can see is the decision tree procedure is there. So now we are able to analyze this process. So now we can see, suppose our question is like this, just for before starting our actual, some problems or examples, you try to understand the logic, how we are going as a decision tree and we are able to achieve a goal, means your target. So first thing is we can observe this. What we are able to do is there is a day, some 10 days data is with you. So what is this data is weather is one data. What is the classification here? Weather, mm, uh, whether is a sunny or cloudy or rainy, something like that. We have the different categories in the weather. And the temperature, it may be hot or mild or anything cold. So these are the another three features. Then humidity. So what is the humidity? Humidity is high or normal. So this then wind speed. The wind speed is weak or strong and something like that. We are dividing. And what is your outcome? Or this we call it as a outcome. What is the question is here? Whether you are going for gym or not, or play for cricket or not, something like that, based on your or outside, you want to go out or something. So, what is your the conditions first day? It is all supervisor learning. Therefore, the input variables is this thing: weather, temperature, humidity, wind. So based on that input, what we will do is we'll decide whether I'm going to play or not. Suppose sunny, weather is sunny, humidity is high, wind speed is weak. In that case, I'm not play. Then another one is cloudy, and then temperature is hot, humidity is hot, wind is peak. Then you can say yes. So something like that, we are able to follow your these conditions, and finally we are able to get our output. Whether output categories are two, whether we are going to play or not. This is the example of a decision tree. In that you can see what we can do is decision tree is upside down because we start with a root node to the top and then it is splitting several nodes. We are reaching as a end side. So the decision trees are nothing but the bunch of if else. So we are always checking whether if is this, we'll go for S. If else if it will be like this. So like that, it is all about if else condition only to select leaves and all. It checks if the condition is true and if it is, then it goes to the next node attached to the decision. Now we can see our example in the below diagram. What we have is there is a tree. We'll first ask whether what is the weather, that is a condition. So in our case, we can straight away we can able to do if they wish. So but now what is our condition is a weather condition. So in the weather condition, what are the attributes are there? There is a sunny, cloudy, rainy. These are the three attributes. It will if there is a strong wind or a weak, if it is a weak window and it rainy, then the person may go and play. Like that, suppose if it is a cloudy, yes. Again, you want to check sunny, humidity is there or not. If humidity is there, again we'll go inside. Is what we call it as decision is humidity is high, then will not go for play. That's what no. and decision is nominal, then you go for the budget. That's what we can able to divide this humidity and wind strong. Wind is strong, then will not go. Wind is weak, will not go. Not only one condition because it is under raining. So now we can see if any situation we can easily get identify what is your answer. So in that case, you can see first thing is sunny, hot, high, weak. So what we taken in this case, you can see here weather is our root node. So we have a lot of call as features. In that I taken as a weather. Why I taken only the weather? Why not immediate? Why not wind? This also we can check. So any one of the node based on our calculation, you have to select the root node. For selection of root node, we have as a procedure that we can see it. So now what we are happening in the flow chart, if the weather is cloudy, then we must go to play as per this. So weather is a cloudy, then it is saying as a S. That's why if weather is cloudy, you must go for play. And other observation you can see, why don't it split more? So why did to stop here? That is also one question. In any point of time, what are the attributes you are going to select as a root node? After that, there is a sub nodes, then leaf nodes. Like that, we have a set of procedures. We already prepared that thing. Based on the procedure, we are going to divide. It can be see training data set always yes for cloudy weather. Since there is no discord lines here, don't need to split further. So we don't want to divide. If any feature is there further, we can able to divide it. The main goal of this machine learning is describe uncertainty or disorder from the data set. They use the decision tree. So using this, while implementing the decision tree, main issues arise. How to select the best attribute for the root node and for the sub node. That's what I divided. How to select as a, we call it as a best attribute as a root node. That is the major thing. Otherwise, what will happen if you select as a root node is other one, it will take time to get your result and it will leads the inaccuracy. So that is also major problem. That is the reason what we'll do is we have to select the root node. So to solve such problem, there is a technique attribute selection measure, that is ASM. This is the technique we have to use to select as a root node. So for that, we measure, you can easily select the best attribute for the nodes. There are two popular techniques. This major technique is a attribute selection measure. Attribute selection measure. This is a root node. And then there is another popular technique is ASM. That will not be considered attribute selection measure. That is ASM will not be considered. There is an easily best attribute will be two popular attribute. One is information gain, another one is a Gini index. These are the two classifications to select as a root node. One is information gain, another one is a Gini index. These are the two things we are using to find as a decision tree. In that, first we'll see information gain. So information gain is the measurement of changes in entropy after segmentation of data set based on the attribute. So it will measure the change of entropy. We'll see that entropy also. So based on the calculation of entropy, we are able to decide the segmentation. That will be the, and it calculate how much information feature provides us at about a class. So this also we calculate the how much information it will provide to the class. So according to that, accordingly to value of information gain, we split the node and build the decision tree. So how to split the node? Based on the root node and based on the two categories we have, that is a information, this what we mentioned, information gain. Another one is a Gini index. Based on that, decision tree algorithm always try to maximize the value of information gain. So this algorithm will be maximize the information gain, and node attribute have the highest information gain is split first. How to split is, the once if we calculate the information gain, which is having as a highest information gain, is going to be split first. It can be calculated using the another formulas as well. So there is a information gain we have as a formula. So what is the formula is entropy of S. S is a one root node and minus weighted average into entropy of each feature. Based on this formula, we are able to get the value of information gain. This formula is used while you are calculating. In the information gain, entropy of S minus what we can able to do, you can see this weighted average into entropy of each feature. Now your feature may be a weather condition. So now what we'll do is entropy of something yes or no in the based on the situation, and weighted average you have to take, and then entropy of the weather or entropy of something another feature, something like that. And what is the entropy? Entropy is a metric to measure the impurity in the given attribute. So in the given data set, we have to find what is the impurity level in a given data set. So that's what is to measure what you call it as a measure the impurity in a given attribute. So we have to measure the impurity. It specify dominance in the data. Entropy can be calculated as, this is a very important formula throughout this decision tree. Probably we must use this formula. Entropy is measure the impurity in a given attribute. So it will measure impurity. In that, entropy of S or any particular situation, that minus P of S or S or no, or you can say that positive or negative, something like that, we can able to divide. So that entropy is measure the impurity. So therefore entropy is minus P during S condition and minus P during no condition. So one by one, where S is the total number of samples, P of S is the probability of S, and P of no is probability of no. So this is the entropy. So based on the value of entropy, we can decide to um, find the impurity. That's what we can say. So next one is a Gini index. So what is the first one? Information gain. This is the one. You can see we already know these are the two categories here. Information gain and Gini index are used to select the root node. So information gain we will get it using this formula. And the entropy is a metric to measure the impurity in a given attribute. So it is not a random in data, impurity in a given matrix. So in this, you are calculating probability of S into log 2 base probability of S minus probability of no log 2 base 2 we can get under no condition. So these are the things. Then again, Gini index is a measure of impurity or purity used while creating a decision tree in the chart algorithm. There is a different algorithms I noticed you. In a chart algorithm, we can able to solve our decision tree. The attribute with a low Gini voltage, the attribute with can see now in only creating a binary splitting, the chart algorithm used in the Gini index to create the binary splitting. We observed while you are going for splitting as well. Gini index can be calculated using this formula 1 minus sum of the probability square. This is the formula for Gini index. And then already I mentioned one sentence in the previous case, pruning. Getting an optimal decision tree will go for as a there is a pruning. So what is the pruning I told? Whatever the unwanted leaves are there, that is going to be discarded to reduce the decision tree size. Pruning is a process of deleting the unnecessary nodes from a tree in order to get the optimal decision tree. This is what we are more precisely we have to do. If it is unnecessary nodes are there without changing their information. So what we'll do is without changing their information, we are going to do this. Pruning is a process of deleting the unnecessary nodes. Process of deleting the unnecessary nodes from a tree that we call it as a pruning. A tool, large tree. Large tree increases the risk of overfitting. That is also problem. If your use data is there to train, then it is going to be overfit. Once the model is overfit, it perform the training is better, and then for testing is the performance is not best. That is what there is a risk issue will be there. Another risk is there. Small tree may not capture all the important features of a data set. But if you are using as a small tree without considering all the what we call it as you know there is a features, then automatically you are able to lose your major information. So that is the problem we are going to arise. So that is the reason we can able to so that is only the reason we need to select the optimal decision tree. For that, pruning is a process to delete the unnecessary nodes. And therefore, a technique that decrease the size of the learning tree without reducing accuracy is known as a pruning. So that is what pruning, what will do is the decrease the size of the learning tree without reducing accuracy. This is the major point in this case. So for that we can, there is a pruning techniques, cost complexity pruning, reduced error pruning. These are the two techniques are there. You can see the pruning is another method that can help to avoid overfitting. That's what I already mentioned. If you are getting as a huge data, then it may get as a overfitting also. That will avoid by using as a pruning. Improve the performance of the tree by cutting the nodes of subnodes which is not significant. If that node is not given any significance, then instead of using that node in a tree, that leads some other problems as overfitting and all. That is what we are to overcome that. We can able to delete that nodes which is not significant. And additionally, it removes the branches which have very low importance. Like that, there is mainly two ways for pruning. One is a pre-pruning, another one is a post-pruning. So what is pre-pruning? We can stop growing the tree earlier, which means we can prune or remove or cut a node if it is a low importance while growing the tree. So if any node is having as a less significant, we can easily delete that node. So post pruning means once our tree is built, to its depth, whatever we have the classification. Once the model is built, or we can say that decision tree is built, we can start pruning the nodes based on their significance. So that way, but somebody will use more number of nodes and somebody will use only less number of nodes. But whatever consideration, the total problem significance should not be deviate. And we'll see the entropy in detail. Now, based on the entropy only, we are going to select our root nodes and all value of the entropy to decide whether it is impurity is there or the performance is improved or not, all these things. Which should be as a root node, what should be the decision node. So like that, we have to identify by making use of the entropy. And then we are splitting that process now. By splitting, how long we are using this. That is the also we have to find. To decide this, there is a metric called entropy, which is the amount of uncertainty in the data set. So you have to calculate for that. Entropy is nothing but the uncertainty in our data set or measure of discord. So we'll see the example. We can consider, suppose you have a group of friends. You try to understand this. Based on this, we can easily, because all our problems, whatever I shown you in the previous slide, like that the problem they may give, and then new data they may uh, in exam, what they will give in the future data or new data set they will give, they may ask the what is your target based on your what you call it as a data sets available in the previous. Suppose we have as a group of friends decide to go to movie. They can watch together on Sunday. That is their goal. They want to go to movie. They have to decide. In that, there is a two choice. They're considering preliminarily. There is a two movies, but friends are there. Which movie they want to see? That is only the question here. So one is movie name is Lucky. Another movie name is maybe Titanic. Anything. So some two movies are there. Now everyone has to tell their own choice. Somebody may say that as a will go for Lucky or somebody will go for Titanic, something like that. So if with the majority people, the votes, suppose Titanic may get more votes than the Lucky movie, then obviously the decision we can decide something like. Or if it is a both are given as a same or near to same, let it be. So Lucky got 5 votes and the Titanic also got 5 votes. In then it is a difficult to go for selection of the which movie. So it is hard to choose one movie now because the votes of both movies are somewhat equal. So let it be, even if I consider this may be 4 and this may be 5, in that case also it is more or less equal. We cannot take it as a decision. In this exactly we cannot take a decision. There is an equal number of votes of both movies, then we cannot really decide which movie should we watch. So in that case, what we can do is much easier. If the votes of Lucky is 8 and votes of Titanic is 2 or vice versa, anything, if majority are there, then we can easily say that the majority votes is a Lucky, then we'll go for as a Lucky, something like that. So in a decision tree, output is mostly yes or no concept. So what is yes or no? Suppose the question may be, we want to go for a movie. In that one question may arise, which movie? Other question may arise, what is the weather condition? Or other question may arise, what is the, class work or something like that. Or maybe something more, we have any important works during that movie time, all these things. So one by one, based on that classification and division, finally, in your situation, we are able to get our result, whether we are going for movie or not. For that, there is a entropy formula is like this. So negative probability, and again here minus P, positive classification or positive class, and then minus probability of negative class log P. So there is a log 2 base P, or I can say that. So here, using this formula, we are able to identify the entropy value. So suppose the positive probability, positive class may be 5 out of 10. Then what I can write? This may be 5 by 10. And then this into log 2 5 by 10. This is a positive class, let us assume that. And then there is a formula minus is there, and minus, and or out of it may be 6, let us assume that. Positive class may be 6, and or 5, anything is same, just for understanding. And negative class may be 4, then out of 10, 4 by 10 log 4 by 10, log base 2 4 by 10. So now this will be the entropy of S. So whatever the class we are using this, that will be entropy of S. Now like this, we'll get the value of here. So what we'll do is, first we are deciding whether yes or no. In that case, we have to use the entropy formula, positive class probability, negative class probability. Based on that, we'll get it as a entropy. So P plus is the probability of positive class, P minus is the probability of negative class, S is the subset of a training example. At any point of time, let it be, we can easily calculate the entropy. Now we can see the division, you can see that. So the feature 1 is the rated base root node. We have 8s and 4 no's. As I said, it is all, process is always if many number of ifs. So the question. So now the first feature you can see, feature 1, like that many features may be there. I consider as a first one is a feature 1. Let it be as a root node, let consider. In that category 2 classes are there, positive class, negative class. According to our formula, there is a minus P probability of positive class log positive class and minus P probability of negative class, probability of negative class. So log negative class. This is the formula as per I shown you in the slide. Now the question is, as I said, now what it will do, it will measure the impurity of the node. So the degree of randomness, it tells how random our data is. So the pure sub split means either should be getting yes or getting no. So now we can see as per this, what we can do is, suppose a feature has 8s. This feature has a 8s and 4 no's. There is a 4 no's initially. After first slip, the left node, you can see what is happening. It is become as a 5s, and then only 2 nodes. And right side, what is happening? 3s and 2 nodes. Now for the feature 1, we can able to calculate split is not pure because we can still see some negative classes in both cases. Now we can see what is our requirement is suppose 8 members are saying yes for movie, let us do that. 4 members are saying no, then probably what you will write is if those are saying yes, you can write here only yes, and those are saying no, you can write only no in that side. But the decision is not at final because in this classification I'm telling, even though 8 is yes, 4 is no, but the left side again, there is a 2 categories are no and 2 categories are no in the right side as well. And again we are splitting. Now we are reaching as a decision. In a 5-2, what is happening? 5 members are saying yes, 2 members are saying no. So we can able to get no further splitting is there because it is only one, it is concluded. This we call it as a leaf node. This we call it as a root node. So like that we are able to divide. So in that case, what in order to make a decision, we need to calculate the impurity of the split. The purity is 100%, we make a leaf node. So now we can see calculation as per previous this one. You can see 8, 4 and I will write here 8452 as well as the 3, 2. So there is a feature 1 or a what you call it as a root node 8s and 4 nodes. Similarly, it is dividing 5s and 2 nodes. And another classification 3s and 2 nodes. So this we have to go for as entropy. Now in a entropy negative feature because we have started with feature 2 and feature 3 will help to entropy formalize this one. For we can see in the feature 2, as I said, 5 yes are there in a feature 2, 5 yes and 2 no in the positive side. And whereas negative side, there is a 3 um, yes and can see here. Yeah, 3s and this is a feature 3. We'll consider first only feature 2. We'll calculate the entropy. 5 and 2 are the feature 2. In a 5 and 2, what is the P plus? P plus is the probability of positive class. So positive is a 5. Out of how many? 7. Because you can see here, total is 7. 5 and 2. Total is 7 in a feature 2. In that, based on the formula, 5 by 7 probability and log 2 log P positive. So that is a 5 by 7 and minus probability of negative P negative. So what you can write? There is a 2 no's are there out of 7. So therefore 2 by 7 and log 2 by 7. So in this, simply calculate 5 by 7 multiplied with log 2 into 5 by 7 minus 2 by 7 multiplied with log 2 into 2 by 7. If you do the calculation, we got it as a what is the value is 85. So in a feature 2, we got it as a 0.85. So in a feature 2, entropy, we got it as a 0.85. Now we move on to feature 3. So in a feature 3, as we discussed in a tree, 3 yes are there, 2 no's are there. So 3 yes and 2 no's. So therefore probability we can calculate for feature 3, entropy is equal to minus positive class. How many? 3 positive class out of 5 because 3 plus 2 only 5. Total is 5 cases. So therefore 3 positive divided by 5 and log 2 3 by 5 minus negative class, we can say it is a 2 by 5 log 2 base 2 by 5. So this is the formula and we got it as a this F3 we got 0.966. So this is a feature 3, we got it as a 0.966, and feature 2, we got it as a 0.85. Now we can see that the left node means feature 2 has low entropy. So low entropy means that what? More purity than right node. So here entropy will calculate the impurities. So in that. So therefore, what we can get low entropy meaning is nothing but a more purity. As much as possible, entropy value is low, then it will give high purity. And whereas in the purity means in the feature 3, it is saying that greater number of yeses, and it is easy to decide the which classification in that case. Now you can see that higher the entropy, lower will be the purity, vice versa. Entropy is more means purity will be less. High will be the impurity. So automatically impurity will be high. So in this case, as mentioned earlier, the goal of machine learning is decrease the uncertainty in a data set. Using the entropy, we getting the impurity node. You don't know if the parent entropy or the entropy of a particular node has decreased or not. In this case, we bring a new metric called information gain. So there is a, here to understand here two things. One is a calculation of entropy. This value, if entropy value is high, then what will happen? There is a purity will be reduces, or entropy is a less, purity will increases. That is the one concept. But here, your feature 2, feature 3 we calculated, but root node, whether it is satisfied or not. That is also the problem. In this case, for that, we are using as a another information gain. This is one of the method we are using in the decision tree. Based on this information gain only, we are able to identify the what we call it as a root node. So we can see in the information gain, there is a formula EY, entropy Y minus entropy Y with X. So this you can see that let's consider suppose our entire population has a total of 30 instance. Let's consider your matrix will be 1, 2, 3 up to 30 instances with different features. One is your output target. This is the, now we have to calculate the information gain. And the data set is to predict whether the person will go to gym or not. Let 16 people go to the gym, 14 people don't. So now we have two features to predict whether she or he will go to gym or not. That's what we are calculating the information gain measures the reduction of uncertainty given in some features. So uncertainty it is going to be reduces. So if you calculate the information gain, that will reduce the uncertainty, just the entropy of a full data set, the entropy of the data set given some features. So now we can consider this problem. There is a feature 1 and feature 2. For this problem I'm telling. So how many total 30 instances are there? In the data set, 16 people going for gym and 14 is not. This is what the data set is available. Now feature 1 and feature 2 we are selecting. One feature is energy, other feature is a motivation. So energy which takes two values. Energy is high, what to decide. Energy is low, what to decide. Similarly, motivation. If no motivation, what to do? Or neutral. Another one is high motivation. So based on this instances, we are able to identify the thing. Now we can see the information gain. Feature 1. is a energy. Suppose if I take it as energy is a root node, in our previous problem as per this, I'm explaining theory part only. The tomorrow class, we are going to give elaborate problems also, so that it is easy for you to understand the theory concept as well. So now here what we are doing is a energy is a one feature. Another one is a motivation is another feature. Like that, we may have the different data set. You can see somewhere it is given data sets and yeah. So here I will show that. In that case, first I taken as a energy is a our root node. Let consider energy is a root node. In that, what is given? 16 people is positive class is going to gym, and 14 are going to are not going to gym. Then in that case, energy is a feature. Another classification is what? If energy is high, what will happen? If energy is low, what is the condition? So in that 16 plus 14 out of 30, energy is high, then it will go to gym as a 12 members. Because energy is high also, but one guy is not going to gym. That is one classification here. And another one is energy is low, then 4 members only going to gym, the rest is not. So in that, we can use the two features. One is information gain to decide which feature should be root node, should be placed after the splitting. So now we have to consider energy is our root node is correct one, because many features is there. One by one we are checking, and based on the check we are able to find whether we are going to select energy is a root node or a what another one is given as a, in a problem, the motivation. So energy is a root node I have to consider, or motivation as a root node I have to consider. Based on this, we can able to decide. Now from this, let's calculate the entropy. So first we are calculating the entropy for the parent node or a root node. What is that? Here, feature 1 I am calculating. So out of 16 positive, as per formula, you know that minus P, formula is known to you, minus P plus mean positive class, probability of positive class log P positive minus probability of negative class into log negative class. So this is the formula. So based on that formula, we are easily calculate the entropy of the root node. So what is the entropy of root node? Total is 16 positive class, 14 is negative class out of 30. Therefore 60 by 30, 14 by 30. So you can see that 60 by 30 and 14 by 30. And that will give 0.99. Entropy of parent is given as in 0.99. And another condition we are splitting here, entropy of the parent node if the energy is high. What is the entropy? If energy is low, what is the entropy? That also we have to calculate. If energy is high, how many positive class? 12 out of 13. And energy is low, how many positive class? 4. So now again use the same formula. You can see that entropy, if parent node only, with energy is high. If energy is high, 12 is there, no? 12 by 13, log 12 by 13 minus as per formula. And how many negative? 1 only negative. So 1 by 13. So that will give 0.39. And that is the left hand side. And what is the right hand side? You can see there is a energy low. See that energy is low, but what is the probability of going for gym? 4. So therefore out of 17, because 4 plus 13, 17, there is a 4 by 17 and log 2 4 by 17 minus, then you can see that negative class is there for the 13 members. So therefore 13 by 17 and here also 13 by 17. So therefore we can able to get our entropy of 3 categories. We can observe that root node entropy, this one, now I got it as a 0.99, And then splitting, you can observe that if energy is high, we get it as a 0.39 is entropy, and energy is low, then we got it as a 0.79 is our entropy. That is one case. Now we'll go for as a weighted average of entropy. In that weighted average of entropy parent node with energy, what is weighted you can see from the data. See that. So there is a, here is 13 and here is 17. So therefore, we can consider the weighted average out of 30, 13 is a positive multiplied with this entropy. You can see formula. I already given as a formula previously. You can observe here the value. Yeah. See 0.39 is our already entropy with high. And out of 30, we have only 13 weighted average I'm calculating. 13 by 30 multiplied with 0.39. That's what I wrote here. 13 by 30 multiplied with 0.39. The rest we can see 17. 14 plus 4. I mean 13 plus 4 is 17. 17 by 30 multiplied with what? This entropy during low. Low is we call it as a 0.79. So here I will write as a average formula directly, average entropy. This average parent energy entropy that is equal to 13 plus 12 plus 113. Out of this is a 30 no. So therefore we can write 13 by 30 multiplied with 0.39, 0.39 plus, what is this value? 13 plus 4, 17 by 30 multiplied with how much? 0.79 already calculated. This is the average weighted I am calculated. That is equal to something we get it. That's what we got it. Now we got it as a 0.62. Now we compare the previous entropy and this entropy. What is the formula is information gain. We'll get it as a E parent. We already calculated in previous. You can see here E parent is 0.99. Then weighted average means average of parent energy we consider that we got it as a 0.62. So now we are subtracting this to 0.99 minus 0.62. That will be 0.37. Information gain is a 0.37 is reduced. The parent entropy was 99 earlier. This we calculated 99. And after that, what is happening after looking at the value of information gain, I can say that entropy of the data set will be decreased by 0.37. So 0.99 minus 0.62, this is a entropy is going, information gain is going to be decreased. Energy is our root. If you consider energy is our, because more features are there, it may not be only one. One is energy is a one root node. If I calculated, I got information gain is equal to something 0.37. So if I take it as energy is our root node. So similarly, we have to consider the motivation also. Calculate the information gain. For that, you can see there is a motivation, the second feature. How many? There is a 14 positive class and then, 16 positive class, 14 is a negative class. In the motivation, we have another sub like energy. There is a, what we have the energy, we have energy is high, energy is low. This is high, this is a low. But motivation, we have three splittings. No motivation, high motivation, neutral motivation. Now same thing you proceed for the motivation also. Out of 16, we can see here no motivation case. You can see the parent is again same. If we consider the motivation is here, then what you can say that 16 by 30, log 16 by 30 minus 14 by 30, log 14 by 30, that will give us a 0.99. Similarly, we'll come to the motivation. Motivation, first case is no motivation, second case is neutral, third case is high motivation. For all that thing, we will calculate the entropy. As per positive class is 7 by 8, then negative class is 1 by 8. You can take it, we calculated this one. Similarly, neutral, positive class is 4 by 10 and negative class is 6 by 10 because it is 6. That will give as a neutral case. For high case, high motivation, బాబు పవర్ పోయింది. విల్ ఎండ్ ది క్లాస్ టుడే అండ్ విల్ సీ కంటిన్యూషన్ ఇన్ ది నెక్స్ట్ క్లాస్.